All right, so this is your first video review with Mrs. Lawson. So hopefully you don't get too bored and get tired of hearing my voice. Just a couple things. Remember, kind of the purpose of the video is to help you get through the problems if I'm not there to do it. You can pause, stop, rewind, fast forward, I guess whatever your choice. So let's get started. So my students, this problem actually popped up earlier on one of our assignments. But there's some other questions, so we'll just go ahead and go through this. So on any of these graph problems, make sure you read the graph. I would label the axis, which they ask you to do on A, and go through and label those key points. So those key points, again, are always going to be our y-intercepts, our x-intercepts. Here's the other one, 11.5. And our vertex, so we're going to say it's about at 6.5 and -24. And these are all just approximate. And again, usually we have arrows, but since this is a situation in context, we don't need to worry about the arrows. So on December 24th, the temperature in Anchorage, Alaska in degrees Fahrenheit is modeled by the equation, and here it is, where x is the number of hours from midnight to noon, and y is the temperature in Fahrenheit. So first, again, if you're in my class, x is the number of hours from midnight to noon, and y is the temperature. So one thing I'm going to add that they asked me to do is label one axis, number of hours since midnight, and label the other one temperature in degrees Fahrenheit. So this is going to be temperature in Fahrenheit. And then this one is going to be our time, or they want us number of hours since midnight. All right, so we've got this U, but we don't need all of the U. What we need is just part of it. So the first part we don't need is this side, because over here, the x, the time, is negative, and we aren't going to have a negative time. So where we're actually going to start our graph is right here, okay? And we're going to follow this because we've got time being positive. And in my class last time, we actually just stopped it at 12, about right here, because it just up here it says number of hours from midnight to noon. So of our U, we're just going to only be using this part. And maybe now you realize we've seen this. So let's go through and just answer the questions. So A, we already did. What was the temperature at midnight? So midnight, if this whole thing is the number of hours from midnight to noon, that means our time is 0. And that's what this is. 0 is no hours has passed since midnight. So our temperature is 18 degrees Fahrenheit. If you look, it does say be sure to label all your answers with the correct units of measurement, so make sure you're doing that. This point, they're referring to this point, is known as the y-intercept. All right, D, what was the lowest temperature that night? So the lowest temperature that night is right here. Now there's two numbers, but I only want the lowest temperature, so do not give the 6.5, just say the -24 degrees Fahrenheit. Now, we'll use the other number here. At what time does that occur? 6.5 is not a time. This is 6.5 hours after midnight, so that's going to put us at 6:30 a.m. What's this point known as? This is known as the vertex. Maybe you don't say vertex, maybe you call it the minimum. Same thing. But I think most teachers are going to prefer the answer of vertex. All right, a point 10, -12 is on the graph. So they don't highlight that point for us, but here's 10, -12, and they want to know what that means. So if you're having trouble, remember 10 refers to x. The x-axis is the number of hours since midnight. So this means 10 hours after midnight is 10 a.m. And this -12 is y, and y refers to the temperature in degrees Fahrenheit. So this is -12 degrees Fahrenheit. So what does this mean? It means at 10 a.m. The temp is negative 12 degrees Fahrenheit. So get used to writing some of your answers in complete sentences. If you take any AP test, they are looking for complete sentences, not one-word answers. All right, at what times was the temperature 0 degrees? So this is 2 degrees, 4 degrees, 6 degrees, -8, -10. So here's 0 degrees. So it's 0 degrees at 1.5 and 11.5 hours after midnight. So that means at 1:30 a.m. and 11:30 a.m. And you need the a.m. versus p.m. All right, average rate of change. So, sometimes we're abbreviating it like this. Average rate of change, if you remember, is just slope. Slope is where you subtract your y's over your x's, and it wants to know from midnight to the lowest temperature. So from midnight, the x and y coordinate represented is 0, 18. To the lowest temperature is our vertex, so the other amount I'm going to use is 6.5 and -24, and now I just go through and use my slope formula and put my numbers in. So I'm going to subtract the y's. I always like to subtract y's bigger, take away smaller. So I'm going to have 18 take away -24, and since I'm using 18 take away -24, I'll have to do 0 take away 6.5. So whether you need your calculator or not, you will probably need it at some point because we're going to be doing some division here. 18 take away 24, if you add the opposite, is just 18 plus 24. And you get, hold on, because I am going to use a calculator. It's been a long day. There's 42. 0 take away 6.5 is -6.5. This is not a complete answer. You need to get this so the denominator is 1. So I'm just going to take 42 and divide it by -6.5. Got my calculator here. And when I do that, I get this crazy decimal, and it doesn't say to round any specific way, so I'm just going to round to the nearest hundredths. All right, usually, it does not say it here, but on the test, it will say, what does this mean in context of the situation? So again, y, these are all y's, represents the temperature in Fahrenheit. And the x is the number of hours since midnight. So what's happening from midnight to here is the temperature is dropping. And this tells us that the temperature is dropping because it's negative, about -6.5 on average degrees every 1 hour. So if you're going to write this out, it just means in context, the temp is changing, average rate of change, so changing about 6.5 degrees every hour. Okay? All right, give the interval of time in which the temperature is decreasing. So interval of time, anything is interval, we're talking about those things with the parentheses. When did that interval start? When did that interval end? So if we go with that, the interval of time where it's decreasing, we're talking about this part here, because here it's increasing. So it starts decreasing at 0, and it ends decreasing at 6.5. And then give the interval of time in which the temperature is positive. So it's positive at 2 levels. So again, maybe you're in another class when you're watching this video. Again, since it just said from midnight to noon, this is the only part that we're going to focus on. And I've got 2 orange parts. When you have 2 parts, you need 2 sets of your parentheses. So over here, one area where the temperature is positive is from 0 to 1.5. And then the other place where it's positive is from, and I never marked this spot, this ending spot. This was 12.6. All right, is from 11.5 to 12. Okay. All right, let's move on to the next question. So same idea, different graph. So this one is the path of a golf ball can be modeled by this. And y is the height, so I'm going to go ahead and just put that. This is the height in feet. after it's traveled a horizontal distance of x feet. So this is the distance traveled in feet. And part A asks me to label it this way anyway. So again, y is height in feet, but this is how far the ball went in feet. All right, so before I start anything, as my students know, you need to mark your x-intercepts, 0, 0, 300, 0. You need to mark your vertex, which is 150 and 100. And my y-intercept is also this x-intercept. All right, so part A was label, height in feet, did that. Label the other, distance. All right, approximately what was the height of the golf ball? So height, I'm looking for y, when it's traveled 90 feet. So I'm just going to go over to 90 and up, and it's going to be about 84, 85, so about 84 feet high. Whoops, sorry, you couldn't see that. All right, how far from the tee did the golf ball land? So this is where you're starting. At 0 distance and 0 height, the ball is sitting here on the tee. So how far has it gone when it's landed is all the way over here. And you need the 300 because that's the distance of the ball. So 300 feet, I think that's pretty good. I don't really golf, just top golf. All right, what was the maximum height of the ball? So most of you are going to go to the vertex, but remember, I don't want both numbers. I want the maximum height. And y is the height, and that's the distance it went. So I'm going to put 100 feet. All right, at what distance from the tee did the ball reach this height? Well, then I'll take the other number, 150 feet. Sometimes I'm writing feet, sometimes I'm abbreviating it. All right, hold on, I'm taking a sip. All right, what domain? So if you remember, domain are all the x values. So what x values make sense in this problem? So again, like the other one, this is where the ball is starting. So I'm not going to go back in distance. I guess I could hit the ball backwards. But when we're talking the part of the parabola that makes sense, it's from when the ball is on the tee and it's going in the air to where it lands over here. So when I look at the domain, the beginning of it, the x, to the end of it, x, a domain of 0 to 300 feet makes sense. So I'll put feet down here. All right, find the average rate of change with this interval. So maybe you haven't seen this appear like this. When they're saying they want to know if x is 25, I'll have to look at the table to get the y. And if x is 90, I'll need to look at the table to look at the y. So if x is 25, I would say it's 30. And if x is 90, here x is 90, and again, I'm going to say about 85. So again, average rate of change is when you subtract the y's over the x's. And I'm going to choose to subtract 85, take away 30, which means I have to subtract 90, take away 25. So 85 take away 30 is 55, 90 take away 25 is 65, right? And now I'm going to get this down to 1 in the denominator. So I'm just going to turn on my calculator and do 55 divided by 65, and it's 0.85 is how I'm going to round it. And again, what that means in context of the situation is 0.85 is y. Y was the height. And the 1 in the denominator is the distance. And in context, even though it doesn't ask, it will ask on the test, is the ball is moving, changing 0.85 feet, so almost a foot every 1 foot it goes in distance, something like that. Okay? All right, last question.